Hi, I'm Mike Stanzik and this is Digital Electronics Classroom. Today we're going to be looking at event detection using flip-flops. So what we're going to do here is look at a situation in which we want an alarm to occur, and then the alarm will stay alarmed even if the situation is changed. And so once the alarm goes off, the alarm will continue. This is sort of like if your door gets opened on your house alarm and your house alarm is going, even if you close the door again, the house alarm will continue to go until you enter the reset code. We're not going to look at a reset code right now, we're just going to look at the alarm staying on even if the situation changes, and look at how that works using a memory element as a flip-flop as a memory element. Okay, let's get started. So we're looking at event detection. And so I want to create a situation. So let's say we have a function that's separate from the detection, except that when an alarm occurs, we don't care what the output is. And then here's my alarm. So my alarm is going to go off when it's an input of 011, or if it's an input of 110, or if it's an input of 111. And so I'm going to build up two of these Karnaugh maps so I can write an expression for both my function and the alarm. And so let's take a look at what we got. So the function is 110x and then 01xx. Okay, and then the alarm is 0001. Make sure we skip, and 0011. All right, so let's take a look at the function first. Remember, I can box x's, but I don't have to. So I got a nice big 4 right there, and then I have a 2 right there, and that's as best I can do. Okay, and so I can write f as equal to the 2 here. Remember, it's x, y, z. So we got not x and not y. So not x, not y. Or x doesn't matter here, and then what's the same on this one? It's a z. So x not, y not, and y not, or z. Okay. So then we can do the same thing for the a. This one doesn't have as many to box, so we got 2 boxes of 2. And so we have a is equal to this column, which is yz, so y and z, or this row is x is 1, and then what's the same up here is y, or x, y. So those are our two functions. And so we're going to implement these functions, and on the output of this function here, we're going to have an indicator to indicate that we have achieved that. Okay, and then on the output of the alarm, we're going to also have an indicator, but we're going to also have a flip-flop. So a flip-flop indicator that will hold the state. So we'll hold the alarm. Okay, that's what we're looking to do. So what I'd like to do is go over to Multisim Live and build this circuit out for us, and so we can see that it working in action, and I'll explain how it works once we get over to that point. Actually, let me explain a little bit right here of how that flip-flop's going to work. So when the alarm gets triggered, there is a transition of A transitions, A goes from 0 to 1, okay? And so this is like a rising edge. And so we're going to feed this rising edge into our clock on our D flip-flop. Okay, so then when the alarm is triggered, it's actually going to clock our flip-flop. And then we're going to put in a 1 into our flip-flop. And so the cue here that starts at 0 will become a 1, and it'll alarm, right? So when the event occurs, event will turn Q to 1. Now, this is not going to change at all because the input is set to 1. So once it becomes 1, it stays at 1. So it'll turn to 1 and stay at 1. And at this point, we don't know how to reset this, so it'll always stay at 1 until we reset the whole program. Okay. All right. Yeah, that was worthwhile. Let's go ahead and change to Multisim Live and go ahead and build this out. So if you look at the two expressions, we have x bar, y bar, and z, yz, and xy. So I need everything except z bar. So I'm going to start by putting in some digital constants. We'll do that here. I'm going to rotate them actually. So we're going to put it here. Oops, no, I want it right on the grid line. Don't be like that. There we go. Right on the grid line. Right on the grid line, great. And then I want some inverters. And we're going to just not label these, but know it goes x, y, z from left to right. And we'll rotate this, and I want this one to be in the middle, right there, looks great. And then we'll duplicate that right there. Awesome. So we have x, y, and z, and then we'll have x naught and y naught, and then z naught doesn't need 1. We also, in our expression for f, we need an AND gate and an OR gate, both of them 2 inputs. And so we'll take a 2-input AND gate, we'll place it right here, and then we'll take a 2-input OR gate, and we'll place it right here, and then we'll take 2 2-input AND gates. So duplicate that. And then a 2-input OR gate. We need this for our expression for the alarm, which is YZ or XY. So let me wire this up. So this first term in the F is X bar, Y bar, X bar and Y bar. So this is going to be X bar right here and Y bar right there. And we'll go ahead and connect to this like so. Okay, great. And then we OR that with Z. So we're going to OR this together with Z. Okay, so this is X bar and Y bar ORed with Z. For the alarm, let me just connect intermediately here. The alarm, we have YZ or XY. So this will be Y. This is Z. This is X. And this is Y. You guys can probably see the benefit of setting it up nicely like this with these vertical lines representing my inputs. So it's really easy to connect to where I want to go. All right, so now I have F and A coming out of these two. So I want to build an indicator for each of them, and our indicator is going to be an LED. This Multisim Full has a digital probe that you can just tag on there and it lights up, but they don't have that in the live version, so I'm going to have to build LED circuits for this to occur. So I'm going to make one, and I'm going to put them over here so we have room for our flip-flop. One for each of the alarm and for the function F. And then we need a ground and we need a resistance. And go ahead and rotate that as well. And we'll change its value here to 220. I also like my LEDs to, going into the settings here, I like them to be white. I think they just look nicer. So now they're white. And then we need to connect these guys to the ground. All right, perfect. So the function can go right to its LED, okay? And we should be able to run this right now and run through the truth table and see the function in action. So 000 should be on, and it is. 001 is going to be on, 0, 1, 0 is off, and then we have 1, 0, 0, and that one is off, and then 1, 0, 1 is off. Oh no, 1, 0, 1 is on. And what about 0, 1, 1? We don't care. Turns out that it's on, but we don't care. And 1, 1, 0, we don't care. Turns out that it's off. And then 1, 1, 1 is on. So we don't care about those. Those were X's, so it doesn't matter. We didn't connect up to the alarm, so nothing happened with the alarm. If I were to connect to the alarm right now, we would get alarms. Actually, let's do that. I can't do it because it's running. Good idea, team. Let's take a look. All right, when should it alarm? It should alarm on 0, 1, 1. We gotta start it up again. So 0, 1, 1, it should alarm. Hey, it's alarming, right? So the alarm's going off. You can imagine you walked into your door and it's beep, 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 and then you close your door and it goes off. Well, that's no good. So, you know, that someone broke in your house and then closed the door, they just have to close the door right away and then the alarm would go off. We need to make sure that it stays on. And that's where the memory element comes in. So I'm going to break this line here, and instead we're going to put in a flip-flop. So we'll put in a D flip-flop, and right here will be good. And now I'll connect the output of the flip-flop to the indicator, okay? And then we're going to, remember, not go to D, we're going to go to the clock, because we want that positive transition from 0 to 1 to clock the flip-flop. And then we're going to set it to 1. Right now it's at 0, it starts at 0. We're going to set it to 1 when that situation occurs. To set it to 1, I need 5 volts here, so I'm going to put a voltage source, DC voltage source, right here. It defaults to 5 volts, so we're good. And I connect the negative side to ground, and I connect the positive side to our D. Don't worry about the reset or set. Those are direct inputs that we're not dealing with at the moment. So let's see what happens this time. So we're starting at 0, 0, 0. Great. And then we go 0, 0, 1. Alarm's still off. 0, 1, 0. The alarm's still off, but now 0, 1, 1. The alarm goes on. So the door is alarming now. Beep, 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 right? Oh no, shut the door, shut the door. So you shut the door, and guess what? The alarm is still on. And so I can go through all the different states here, and it doesn't matter. The alarm will stay on the rest of this time because it's held in memory by this flip-flop. Once we set it to 1, it's not going to change from 1 at all. So this is what we're talking about for having a event detection and then maintaining the memory of that detection. And here it is. So, all right, so that's it. Thanks a lot for watching. I hope that makes sense. And we'll use this event detection again later. And when we're looking at our shift registers, and we do a little problem with that, detecting a state. Yeah, so this is Mike Stanczyk, and this is Digital Electronics Classroom, and I hope you have a wonderful day.